The first function that we need to examine is fopen. You can't do any file manipulation without calling fopen, so it's probably the most commonly used and one of the most therefore important functions that we can use. It's used to open a file for reading, writing or appending. And it doesn't matter if it's a text file or a binary file, it'll open either one just as easily. It's called like so. You call it, you pass it the name of the file, which is just a string. You can pass the name being, you can just say fred.txt, you can pass that as the name, or you can do a full path name like c://my documents \fred.txt. Either way, that will be all contained in the string passed in as name. You also pass it a mode, and the mode we'll have a look at now. So you'll see in a second what the mode is supposed to be. Now it passes you back a pointer to the file handle, and you use that file handle anytime you ever want to refer to that open file. Close that file when you have finished, so therefore you pass it to the reads and writes as you would expect. Possible modes are R for read, W for write, A for append, RB for read a binary file, WB for write a binary file, and AB for append a binary file. The first three are all text files, the last three are all binary files. So thus you get to specify in the mode two different things. You get to specify what type of file you're opening, and you also get to specify how you would like it to be opened. Notice these have to be passed in inside double quotes. They are passed in as a string. There are a few other modes that you can open files in, but they're not very commonly used, not important, and I'm not going to go into them now. Look them up in the reference texts if you need to. Notes on using fopen. Obviously all open files should be closed. You should get into the habit of doing this. Every time you write an fopen, go automatically and write the fclose for it somewhere. Just get into the habit of doing that. Now, you can get away with it. I mean, if you don't do that, then the operating system will automatically close all open files for you at the end of the program. But it's not a good idea to rely on that. You can get into the habit of relying on that, and you can leave files open that don't need to be open, and you can run out of system resources, or you can try and open files and find that you can't. All sorts of errors can occur if you don't. So just get into the habit of closing files automatically, even if you know the operating system is going to do it for you. If you open a file for writing, then any previous contents of that file will be lost. As soon as you do the open, as soon as the open call is made, before you even write to the file, as soon as the file is opened, if that file contained anything originally, those contents will disappear. They'll just be erased. And you can't get them back using the recycle bin or anything like that. They're just gone. Files opened for appending do not need to exist. In other words, you can append to something that's not there. All that will do is it will simply create the file for you. And std in, std out, std, they're all opened automatically. You don't need to open them yourself. Fclose, well, that's a pretty simple one. You just use it to close a file that's been opened with fopen. Don't ever try and close something that was not opened using fopen. It looks like this. The fp there is simply the file pointer or the file handle that you pass in from fopen. Whatever variable you use to store the file handle, simply pass it in as the first and only parameter to fclose. There is no return value. It simply does what it's supposed to do. And as I said a moment ago, all open files are closed by the operating system at program termination. Again, it's not a good idea to get into the habit of relying on that. Next, we've got fprintf and fscanf, which are exactly the same as printf and scanf, except that you get to specify which file you want to read or write to or from. In other words, you get to specify a file handle. fprintf looks like this. It's exactly the same as before, except the very first parameter is the file handle. It goes before the text formatted string that you want to output. fscanf is pretty much the same, and so I don't really need to go into too much detail on fprintf and fscanf. In fact, this is all I'm going to tell you about them. If you ever write a printf line that looks like the following, printf the answer is whatever, that's exactly the same as writing fprintf to std out. The answer is, and so on. Of course, you could replace std out with a file handle that you got from fopen, and thus you could write the words the answer is whatever, the answer is 6, into any text file that you want. It's very handy to be able to do that. And similarly, fscanf works the same way. Okay, so we don't need to talk too much about that, etc. fread and fwrite. Okay, now you won't have seen those before. They're a little bit trickier, but they're actually quite easy to get the hang of. So let's have a look at those. They're used to read and write data to and from binary files, not exclusively, but almost always. They look like this: fwrite. You pass it 4 parameters. You pass it some memory. You pass it the address of some data that you want to write out. Notice that is a pointer to a void. You don't know what a pointer to a void is yet, but just pretend that's a pointer to anything. It doesn't matter really what it is. We're going to learn about void pointers in a later chapter, and you'll find that they just mean they're pointers to anything. So what that's trying to say is it will take a pointer to anything as its first parameter. And that data is considered to be a collection of items. In other words, it's an array of things. It's thought of as an array of things. And the second parameter says how big each one of those things is. So you typically use size of as the second parameter. Size of an employee, or size of an integer, or size of something would be the second parameter. The third parameter is how many there are in the array. It may only be 1. You may only be writing a single thing out. In other words, count would be 1. And finally, you specify the file handle of where you want to write it to. Fread is exactly the same, except this time you specify in data, you specify an array or an area of memory that you want fread to put the data into. And if you multiplied size by count, you would get the size of that array in bytes. Again, it's exactly the same. But it's a little bit different in that fread will read them in size number of bytes at a time. Let me explain. Let me give you an example of what I'm talking about. Let's say your array of data is 50 bytes in size, and it's 5 things. There's going to be 5 things in the array, and each one of them is 10 bytes in length. What fread will do is it will read them in 10 bytes at a time, because you've said that size is 10 and count is 5. So the size of the thing is 10 bytes, so it's going to read them in lots of 10 bytes. It's going to read 10 bytes, then it's going to read another 10 bytes, then it's going to read another 10 bytes, until it's read 5 of them, or until it reaches the end of the file, whichever comes first. So, both of these functions will return count if they were successful in reading or writing all that data. So fwrite will attempt to write out 5, again let's use the same numbers, 5 lots of 10 bytes, and if it was successful you'll get the value 5 back, saying yes, I successfully wrote out 5 things. And fread, if it successfully managed to read in 5 things, each of size 10, then it will return a value of 5 as well. They will return -1 if there's an error. Fread will return a smaller number, or 0, if the end of file is reached. So what happens then is, if fread is reading from the file, and let's say there's only 4 items in the file, each of size 10, then you'll get back the number 4, meaning you did successfully read some data, but you only read 4 of them. You didn't manage to read 5 of them. So you've got to check that. When you do an fread, you've always got to see if it successfully read the data, and when it finally says the number that it read in was less than the number that you asked it to read in, you know that you must have reached the end of the file, and thus you can stop trying to read and you can just simply close the file. Okay, I'm going to give you examples of those in just a moment, so you'll see exactly what I'm talking about here.